In this video, we are going to be introduced to what molar mass is. Molar mass is the mass in grams of 1 mole of a substance. The symbol that we use for molar mass is big M, and its units are in grams per mole. If you take a look at your periodic table then, we know that our periodic table tells us the atomic mass of each of the elements. So the mass of one atom of an element, for example, one oxygen atom we know has 16.00 AMU, or average atomic mass units. However, the periodic table also tells us what the mass of 1 mole of an element is. So looking at oxygen again, it tells us that 1 mole of oxygen is 16.00 grams. So we can get the molar mass of any element off of the periodic table. We can find the molar mass of compounds simply by adding up the molar mass of each of the elements that makes up the compound. So this is where your counting atoms is going to come into effect here. For example, if we want to find the molar mass of iron 3 sulfate, what we need to do is add up each of the molar masses of each of the individual atoms that make up the compound. So the molar mass is going to equal to 2 times the molar mass of iron, because we have 2 atoms of iron, plus 3 times the molar mass of sulfur, because there are 3 atoms of sulfur, and 12 times the molar mass of oxygen, because we have 12 oxygens. So if we look at our periodic table, iron is 55.85 grams per mole, and sulfur is 32.07, and oxygen is 16.00. Alright, so if we add all of these together, you get 399.91 grams per mole. Molar masses are always to 2 decimal places because the periodic table we're using always has 2 decimal places. We don't consider the number of atoms as part of our significant digits because they're whole numbers. We can't really divide them. There is no uncertainty in those measurements. So always to 2 decimal places for a molar mass. We can then use a formula to convert between moles and mass. So the formula is that the mass is equal to the moles times the molar mass, or little m is our mass, which we're going to put in our triangle here. N is the number of moles, and big M is our molar mass. Let's look at a couple of examples then using this equation. So our first example is that we've got a flask with 66.0 grams of carbon dioxide, and we're asked to find how many moles there are in the flask. The formula we want to use is that the moles is equal to the mass divided by the molar mass. So carbon dioxide has a formula of CO2. To find the molar mass, you're going to add up carbon, which is 12.01, and oxygen, which is 16.00, multiplying that by 2. So we're going to have 66.0 grams, and if you find the molar mass of carbon dioxide, you should get 44.01 grams per mole. And that means that the number of moles, and we want 3 sig digs, is going to be 1.50 moles of carbon dioxide. We can take this one step further and find the number of molecules present in 66.0 grams of carbon dioxide. So from the previous question, we found that the moles was equal to 1.50 moles. Now if you looked on your calculator, you had more digits than that. So you had, it should have displayed something like 1.4996 and kept going. anytime we're doing calculations, you want to keep all of your decimal places until your very final answer. So you'd want to put in the 1.4996 ... into your calculator rather than just 1.50. And that's because we want to avoid rounding off errors. So remember, to find the number of molecules, you're going to take the number of moles and multiply by Avogadro's constant. So taking that number and multiplying it by 6.02 times 10 to the 23, two significant digits is going to give us 9.03 times 10 to the 23 molecules. Our third example asks us what is the mass of a sample of iron 2 chloride that contains 3.50 moles. So iron 2 chloride, remember, is FeCl2. To find the molar mass, you're going to take 55.85 grams per mole for iron. You're going to take the 35.45 grams per mole for chlorine, multiply it by 2, add those two together to give you a molar mass of 126.75 grams per mole. So in order to, we don't need that. In order to find the mass, we're going to take the number of moles, multiply it by the molar mass. We're given the number of moles is 3.50 moles. We're going to multiply that by 126.75 grams per mole. And when we do that, we want three significant digits in our answer. It's going to give us 444 grams of iron 2 chloride. So that is our final answer. Finally, again, we can take this one step further and combine both of the equations that we've used to date. So what is the mass of iron 2 chloride sample that contains 5.67 times 10 to the 24 molecules? We first need to convert the number of molecules to the number of moles in order to find a mass. So to find the number of moles, we're going to take molecules and divide it by Avogadro's constant. 5.67 times 10 to the 24 molecules then, divided by 6.02 times 10 to the 23 is going to give us 9.4186 ... moles. Again, don't round off here yet because we're not done with our calculation. Instead, what we want to do is find the mass, and the mass we know is the moles times the molar mass. So we're going to use our big long number here, 9.4186, so on, moles, multiplied by our molar mass of iron 2 chloride, which we know from the last problem was 126.75 grams per mole. And that is going to give us 1,193.8 ... grams. So looking back at our problem, we have 3 sig digs in our question, and every operation we did within our problem was either multiplication or division, meaning that our answer should have 3 sig digs. So to represent our answer to 3 sig digs, we got to put it in scientific notation, which gives us 1.19 times 10 to the 3 grams. So that would be our final mass.